Welcome again. Our next speaker. I would like to say hi to Peter Droege from Maddox. And Peter is going to talk about AI-based optical inspection for everyone with a money-back guarantee. So looking forward to your talk.
OK, thank you. OK, you can hear me. So I'm Peter. I'm one of the co-founders of Maddox AI. And I think we've heard quite a bit about how AI might be able or might not be able to solve certain vision tasks. But I think we haven't really talked that much about what are the additional challenges that arise when trying to develop AI systems. And I want to talk about 3 specific ones today and how we try to solve them. The first problem that we're trying to solve is, we all know AI feeds on data, no? But I think we also all know that even if we have a large labeled data set, this does not guarantee that we have a good machine learning performance. And why is that? If we look at how a machine learning model can be optimized, we basically have 2 levers, or 2 main levers. One being the optimum machine learning architecture, so the number of layers, the augmentation strategy, the learning rate, etc. And I guess the main enabler for this is that you have top talent. That's why we're located in the Cyber Valley. That's, for example, why 2 of my co-founders are actually professors in the area of machine learning. So I think we've got this one covered. But the second lever is equally as important, and that is that you have consistent databases. And the probably biggest enabler for that is that you have an efficient and user-friendly data management platform that helps you create this clean and consistent data set. And if you have both levers in common, you can actually have all the ingredients to create an optimal machine learning model. And we believe that especially the second lever, the right-hand part, is actually a little bit overlooked and underrepresented. And obviously, we want to change that. So why is that even a problem? We know from real life that humans are not machines. And humans just make mistakes. So due to fatigue, due to subjectivity. And the same is true for the digital world. We obviously have to teach the model what is good or bad. And we have to ideally assist the user who teaches the model to see that he or she did not miss a scratch or did not mislabel something. So ideally, we have some assistance in doing so. And that's what we're trying to build with Maddox AI. So we have several digital tools and agents that help us. And I want to talk about 3 of them. So the first one being, obviously, we do what is called label noise analysis. So we show the same images to different labelers, show the inconsistencies, and then solve these inconsistencies so that we have a clearly structured data set. The second thing we use is what we would call hard negative mining. So we always propose the image that brings the highest additional explanatory power to the model, to the labeler who labels the images. And this way, we actually limit the number of images that we need to label in order to develop an operating model. And then lastly, we simplified the labeling task, because oftentimes there's so many different failure categories that it's quite tough to label an entire image. What we do is we break it down to simple yes or no questions. So we highlight the part of the image where we ask the question, OK, do you see a scratch here? Do you see a dent there? It's a yes or no question. Everybody can answer it. And this way, it's much easier for the labeler to use it. Everybody can use it. And it's a much lower probability that he or she makes mistakes. Jumping to the second problem that we see. I think we see that there already are a lot of AI systems out there, but we also see that all this valuable data that we gather is not really being used as of today, as it is oftentimes siloed. So in a lot of the plant visits that we did, we saw that there are already a lot of systems up and running, but these systems might even collect some data, but this data is not really being aggregated anywhere. So this data is not really being made use of. So we at Maddox wanted to change that. So what we do is we do aggregate all this data. We've built an aggregation layer with different features that we also have not only an automation advantage, but also a digitization advantage, because every automation case is a digitization case as well. So what we have is we have a quality KPI dashboard, so you can see right away how did I do production-wise, quality-wise, how many defects did I produce, what kind of defects did I produce. I have a review feature, so I can review every single model decision. And I also have something what is an alerting function. So let's say there's too much scrap being produced at one of the machines, then I want to know about it. So the shop floor manager ideally should get a text message or an email or something that he or she can take care of the problem right away. The third problem that I want to talk about is a more fundamental one, because we believe the way we procure and also ship AI systems today is not entirely in the best interest of the customer. Because oftentimes, clients do not really have a guarantee that the AI system that they bought works today nor tomorrow. And why is that? We believe that in a lot of projects, I think a lot of the budget for this project has already been spent on kind of the more classic engineering tasks before we actually take a deeper look into the vision system, or into the eye system, or the classic system, the vision system in essence. That's obviously a problem. And then we also know all these projects where they just take forever, because in the beginning we have a smooth running system which works really well, then something changes in production, we have to recalibrate the model again, then the model seems to run again smoothly, but again and again this iteration cycle takes place more than once, and we have to need to recalibrate again, then the model seems to work again, and so on. But in the end, the employees or the users just get fed up with the system. Because it's just too much recalibration, they lose trust, they're fed up, they just stop using the system, which is obviously a mistake and is obviously a problem. So how we try to actually tackle this problem is we guarantee a certain performance, and we also tie our financial compensation to this performance. How does it work? So what we do in the first step is we align on the performance KPIs that we need to achieve. So what is the inspection accuracy? What is the cycle time requirement? And the second step, we then deploy our own hardware at the shop floor from the client. We then use this hardware to collect data, label the data, as shown earlier with the digital assistants, develop our model with the help of this data, and then have a very transparent evaluation phase. So what we do there is we see, did we actually manage to achieve those KPIs that we promised in step one? If that's the case, both the clients and ourselves, we have a positive business case, and the client enters into a subscription contract. If, however, we do not achieve those KPIs, the entire development effort beforehand was free of charge for the client. So we actually share the investment risk, and as it is a subscription-based model, obviously all kind of model redeployments, model retrainings, model updates, and also software updates behind the platform are already included in this subscription fee. So in a nutshell, what do we actually do? Maddox is a data management platform that helps you create clean and consistent data sets, making the most of your data. At the same time, Maddox is not only an automation solution, but also a digitization solution, because every automation project is also a digitization project. And lastly, we actually promise a certain return on investment because we share the investment risk with our clients, so we're completely aligned from an incentive point of view. So to sum up, we can say that Maddox AI is what we would say an AI-based optical inspection system for everyone, because everyone can use it with what we would call a money-back guarantee. Thanks for your attention. Happy to hear any questions.
Thank you, Peter. Peter Droege from Maddox. Are there any questions from the jury members? I see Sigrid has one. Please.
How many customers leave the process?
Say again?
How many customers leave the process at the step 2?
So far, we have a 100% success rate.
Wow.
Wow.
But I mean, to be fair, obviously we choose those use cases as well where we see a quite high likelihood that we manage to achieve those KPIs.
That's honest. Yeah, thank you. Another question from the jury members? Mr. Ersu.
How many customers you have delivered already Maddox AI?
Where it's up and running, we have, I think, 9 systems with 7 customers.
Okay. And what was the average duration for installation, deployment?
The average, I'm not 100% sure. I think the fastest one is probably a week, and the longest one was, I think, around a month and a half, but that mainly depends on data collection phase. So that's usually the bottleneck for us to be.
And who defines during the digitization process the KPIs?
We together with the client. So it's an iteration process.
This could take longer than 1 week?
It can, yeah. So if you talk about how long does it take to sell a product, this can also...
No. I'm talking about deployment, installation.
Yeah, but I mean, we have agreed on the KPIs beforehand, so they are in the contract actually. So once we set up the system, before that we have set up a contract where we clearly defined, okay, inspection accuracy is this, what we need to achieve, cycle time requirement is this. So after the contract is signed, there's no dispute about what we need to achieve.
So from these 9 systems, what was the average price?
Say again? The
average price for the 9 systems.
Yeah. So what we what we usually do is we put in the hardware free of charge. So the average price tag depends on how expensive the hardware is, kind of. So the average cost is probably 2,000 euros per month, including hardware.
Okay.
For the customer.
For the customer, yeah. So he doesn't pay for the... Okay.
And what is the minimum duration for the contracts?
1 year.
1 year?
Yeah.
So 24,000?
Yes.
Sorry
maybe you can explain it better. Yes. I didn't understand.
Sorry to interrupt, Mr. Erzi. Time's running. I propose that after the pitch session, you maybe have a talk at the booth.
But we have to give him some score,
yeah, that's
right?
true. Okay.
With 2,000 per month,
yeah,
there will be no score. Sorry.
I mean, happy to talk to you at the booth. The hardware that we use usually doesn't cost 100,000 or something. If it costs, obviously we cannot sell the system for 2,000 a month.
I'm sorry. I was talking about the total cost for the customer.
Yeah. Yeah, I'm saying it depends on how much the hardware is. If we have a very complex machine where, let's say, if the customer would buy the hardware for one of 200,000, I obviously cannot sell the hardware for free and then only take 2,000. But we have a lot of setups where the hardware maybe is 5,000 to 10,000 euros, and obviously that accumulates quite quickly.
Last question. Total cost for the customer, 24 months.
It depends on the use case. But on average, so far, 2,000 a month, so it would be 48.
Okay, thank you, Peter.